Okay, thank you very much, Phoebe. Yeah, so as Phoebe has said, I'm going to be speaking about the EMC Data Science Associate course today. What are we going to cover? I'm going to speak about who am I? Why am I in front of you? I'm going to speak about what the course itself entails, give you some ideas of why you might want to go on the course, and then where you can go with it, right? And I'm happy to answer any questions about anything at the end. Right, so who am I? Who am I, right? Who am I? I've got a nice slide telling you who I am, right? I've split my biography up into like two sort of sections, when I was in Scotland and then when I'm now in London, right? In Scotland, I was born, I'm Scottish, you might get the accent, you might not. Been in England for a while, who knows? My background, my university background, I did a maths degree, predominantly applied maths. I loved it. I think mathematics is a fantastic thing. It is just a brilliant way of expressing the many problems that the world faces, and it is integral to the sort of world of data science, right? I did a dissertation on liquid crystals. That was quite fun too. However, following my maths degree, I wasn't entirely sure that I wanted to go on to be a mathematics researcher, so I went and tooled myself up in programming, right? Did an MSc in computer science, and it was during that I did a dissertation involving statistical analysis of internet packet traces. And that was the first part of it. The second part of it was a true sort of machine learning task, which was trying to basically decide if someone was watching Netflix or not, based upon the first few packets of data that came into their computer, right? And that really sort of made me realize, I was like, wait, hold on. So there's kind of computer sciences, you know, coding, Java, website building, all this sort of stuff. I was like, oh, it's fine, right? This is fine. The math side of it, I was like, oh, this is cool, but I don't think I could just do this purely. And then there's the beautiful marriage of sort of maths and computer science, which is data science, right? Which is what this EMC course is all about. Okay. Following university, I was a data analytics consultant in a medical technology firm. The idea behind that firm was to get information on medicines as they are used out in the general public, and see essentially whether you could map certain symptoms to interactions between these medicines. So that was all up in Glasgow, right? I then moved to London because I fancied a change, fancied to challenge myself, become an instructor, and I became a data science trainer covering courses including data science, statistics, machine learning, big data, Python, the R programming language, and then a little bit of Scala towards the end. But I have a love-hate relationship with it. And now I'm here, now I'm in front of you. I'm a Firebrand data analytics instructor. As Phoebe mentioned, specializing in provision of the sort of BCS courses, but also this fantastic EMC DSA course. Broadly speaking, that is who I am. Okay, right, what do I want to say next? Who's this course for, right? Who is this course for? To my mind, this course is perfect for perhaps someone who works in business intelligence, who wants to take the next step and start tackling some of the more challenging problems that most companies face today, especially in this world of, everyone's heard of big data by this point, right? In this world of big data, how can you analyze it effectively? Well, it's through using commonly data science techniques, right? So existing business intelligence people, data analysts, right? This is a fantastic course for them. However, you don't have to necessarily have a background in analysis to understand data science, right? You might just have an interest, right? You might come from another sort of somewhat technical area and just be interested in how you can change into a more analytical role, okay? You may even be a manager who's simply curious as to what this whole world is about and wants to be able to have conversations with the data science team about what they are actually doing and feel like you understand what they are saying, right? For this reason, I mean, those are ideas of the kinds of people who I tend to see pop up on the course, right? But at its most fundamental, a data scientist is anyone who fits this kind of profile, right? People have some degree of quantitative skills, right? Some ability to understand numbers, right? People who have some amount of technical aptitude, right? Can turn a computer on and off and maybe do a few sort of extra things, right? Bit of coding, fantastic, right? Understanding of Excel, also fantastic, right? Some degree of technical aptitude. Skeptics, we love skeptics, right? Skeptics are often people who ask the right questions. Okay, and we wrap into that critical thinking skills, the ability to break down a problem into various parts and attempt to solve each of these, hypothesizing on what might be going on. However, you cannot simply be a technical robot who wants to use tools to solve problems, right? You need to have some interest, you need to be curious, you need to have some degree of creativity with the way you approach problems, otherwise you may miss out on a vast amount of things, right? And of course, communication, collaboration. A data scientist is not an island, right? They always work within a team. And in the course, we actually discuss, what makes a good data science team, right? So I gave you job titles before, but realistically, anyone who has this kind of skill set, who feels like they want to develop further a skill set like this, the EMC DSA course is fantastic for them. You might be wondering, what the hell is data science, right? You might have been given an email to this sprint thing and gone, as data science, what is data science, right? Data science is the natural progression to sort of traditional data analysis. Okay, data analysis is typically focused on what has happened in the past, understanding that further, and just getting as strong an understanding as you possibly can about what has gone on, right? Getting as strong an understanding as you can as what maybe might go on in the future, but without any sort of what you might call a model backing that up, right? Data science takes a step in front of that, in that it covers trying to predict the future actively, right? Trying to perhaps associate some label with some piece of data, right? The use of, more often than not, techniques from machine learning, right? To solve problems, possibly bigger problems, possibly problems involving more data than you've been able to handle before, problems that cannot be solved by a single person and may need a system sort of behind them. Data science is an entire world that has exploded. It is a growing job area. It's fantastic. It is fascinating. I enjoy teaching it, right? I enjoy teaching it. I enjoy people learning about it, right? I have a graph that essentially expresses what I'm saying here. Right, I have the option of a little pen, right? We have a little graph describing this, right? Where we have, I don't know, what do we have? We've got on our y-axis, we've got the sort of analytical approach we take in solving a problem. And on our x-axis, we have the time period the analysis is associated with, right? Traditional business intelligence is more often concerned with explaining what has gone on in the past, right? And we generally put business intelligence projects within this sort of category. If there comes a point where you're trying to predict what's going to happen in the future, right? You may need something like data science or techniques from data science to do this, right? If you're interested in an exploratory analysis, right? You may not even necessarily know what it is you're looking for yet, right? Data science has fantastic techniques for that, right? It can uncover hidden patterns in your data that you didn't even know were there, right? Whereas with exploratory analysis, you're more likely to sort of know what pattern there is there and just be trying to express it better. Okay, so it is that sort of next step from traditional business intelligence that data science captures, right? There are so many fascinating things involved with it, right? Another way to think of it is the type of questions you would ask. Business intelligence is often to do with what happened last quarter, how many units have we sold, where is the problem, right? What might have gone wrong? Okay, data science is more open-ended, the what ifs, right? What could be the optimal scenario, right? Many possible answers to that, right? And what will happen next, right? Will these trends continue? What will happen if these trends continue? Why do these trends exist in the first place? Data science is a toolkit designed to help you explain all of these things, or at least allow you to try and explain them all, right? Okay, why has there been such a big explosion in this world of data science? Computers are better now. There's loads more data now, and there's loads more people interested in data now. Right, is my simple answer. So that gives an idea of what data science is. Right, data science takes things to the next level. Right. So what do we cover in the course? What do we cover in the course? In the course, we break it down into roughly sort of 5 chapters, right? The body of the course is taken up by one of the chapters covering the various analytical methods that we can use, okay? But the fundamental parts are as relevant and as interesting. The entire thing is massively relevant and interesting, right? We begin the course simply by talking about this world that I'm trying to explain in sort of a soundbite right now. The world of big data, the world of analytics, the job role of the data scientist, right? What skills should they have? Why are they wanted? What is big data, right? Turns out it's not just data it's not just lots of data, right? Many things factor into big data, right? What can we do? Who do we need to collaborate with? All these sorts of questions are covered in this first chapter. Okay, it gives us a strong understanding of the domain, a foothold, if you will, to allow us to move on further, right? We then begin to think about data analytics projects, right? Every project management, something or other, will have a life cycle associated with it. There are life cycles associated with data, life cycles associated with running projects, life cycles associated with, I don't know, manufacturing, right? There is a data analytics life cycle that we talk about, which again breaks down these fascinating tasks into sort of stages in which you would do them, right? Starting from the inception of a project, hypothesizing on what the problem or the solution to the problem may be, through data preparation to analysis, modeling, evaluating your model, and then the communication and presentation of your results, right? We break these down into sort of granular detail, whilst also talking about all the various people who are going to be involved in each stage, right? Again, a data scientist is not an island. They work as part of a wider team. Okay, so this is sort of soft skills side. We then dive a bit into the technical skills involved in data science, right? Now, what do we have? We say data analytic methods with R, okay? So not only is this a course that teaches you the theory side of the techniques involved, we implement practical applications of them using the R programming language, right? Some of you may have heard of R, some of you may not have heard of R, right? Whilst I was brushing my teeth, I came up with the analogy of R as being, if you were to compare R and Excel, right? Excel's great. Excel is fantastic at so many things, right? However, it becomes difficult to use for more advanced analytical tasks, right? So I thought Excel, you think of Excel as a Prius, right? If we're going into the world of cars, Toyota Prius, right? Nice, useful, great at what it does, right? But probably somewhat limited, right? Nice and quiet. I don't know if that's got anything to do with it, right? Whereas I likened in my head to something like the Mars rover, the Curiosity rover, right? Can do everything that a Prius can do, realistically. However, it has all these extra things strapped onto it, right? Which allow it to perform very specific tasks to solve very specific problems, right? In a wide variety of scenarios, right? Some of the tools you may never need to use, right? In fact, the vast majority of tools you may never need to use. But there are a hell of a lot of tools which you may need to use and which are fantastically powerful in how they work, okay? So we teach an amount of R on the course, right? It's always massively useful to have an understanding of a programming language coming into it, or even something like Excel, something like SQL, right? On which you can sort of base your understanding of R. But R is just an amazing statistical tool. It is the best statistical tool out there. Some languages are catching up, but R is just a fantastic statistical tool, which we use for all of the analysis we perform in the course, right? We will cover some theory. We will then implement that theory in the R language to allow us to actually twist some dials, play around with the theoretic concepts. Okay. So in this module, what we're focused on is the sort of basics, right? The fundamental building blocks of R, right? Data types you come across, how you interact with things, assignment of variables. If you know these, you know these. If you don't know these, you don't know these, but you will learn these, right? Or you will deepen your understanding of these in the EMC DSA course. We then move on to visualization techniques for certain kinds of data. You can't visualize all data in the same way. And so we run through the wide variety of techniques we can use in R. There are many more, of course, but we hit on the sort of core types of graph and things like that. We then move on to speak a bit about hypothesis testing, right? Hypothesis testing is a tool which every analyst should have under their belt, right? We explain it from sort of a theoretical side. We then move on to actually implement it in R and just develop our understanding of what it is we're actually doing when we're testing these things, right? People often think that it's only to do with, science hypothesis testing. However, it can be a fantastic tool you can anchor your analysis around, right? You generate hypotheses. How do you know whether a hypothesis is or is not potentially true? Well, you have to test it, right? You can do this with your models. You can do this with assumptions you make about data. You can do this with so many things. And we really drill down to that in our data analytics methods section. Okay. So this sort of builds our baseline of technical knowledge before we get into what I would sort of describe as the meat of the course, right? Which gets the nice, cool name, Advanced Analytical Theory and Methods, right? It's analytical theory and methods, right? It is the core set of concepts you need to be aware of in data science before you can realistically kind of go on and do anything, right? And we break this down into sort of sets of techniques for solving certain kinds of problem, okay? So, the first thing that we talk about is something called clustering, right? You may have come across it, you may not have, okay? We specifically talk about what's called the k-means clustering algorithm, right? Again, you may have heard of that, you may not have, right? The idea behind clustering is that finding hidden patterns within your data, right? Specifically the finding of hidden groups within your data, okay? Or even groups that you expect to be there, but you haven't labeled as of yet, okay? An example of where this might be applied would be if you have data on your customers, right? If you have customer data, it could be in a finance institution, you could be in a supermarket, you could be in a subscription service, right? All of these places are generating massive amounts of data, and it might do you good to be able to group these customers into certain kinds of customer through which you can send them specific marketing emails, right? You may have data such as, I don't know, the average spend, the average spend of the customer and how often they visit your site. And based on that, you could break them up into, people who often come along and spend a lot. So you might want to bombard them with marketing emails. And you might have people who don't spend a lot very often. You might want to kind of leave them alone, right? And you can have all various different permutations of these things, which allow you to better market to your customers, right? Clustering is immensely powerful. And almost simple when you understand it, right? We touch on a single technique for this. However, there's a world of them out there, but the core technique for that is what's called k-means clustering, right? So that's the first method we discuss. We then move on to talk about something called association rules, which I'm sure we've all shopped online, right? If you're shopping online and you put two things in your shopping basket, right? And you scroll down on the website and the website says, oh, people who bought these items also bought this item, right? 9 times out of 10, that's going to be based on association rules mining, okay? Things that often occur together, right? Yeah, it's the modeling of things that often occur together and the sort of degree of confidence you can have in those rules, right? You bought socks and gloves, right? 90% of people then also bought a hat, let's say, okay? You can boil down those kind of rules of thumb or ideas about a problem you might have in your head into a set of solid rules through association rules mining, okay? It gets used very, very widely. So that's the second technique that we cover. We then move on to talk about regression, something that I think most people will have heard of because it is one of the most widely used analytical techniques out there, okay? We discuss three kinds of regression, right? Simple linear regression, multiple linear regression, and then logistic regression, whose inclusion in regression is somewhat contentious, but it's technically correct for what we discuss it for. Regression at its most fundamental is the using of that equation of a straight line that you probably learned in high school to predict things about new data that you obtain, okay? A great example of a linear regression problem would be if you were trying to see if there was an association between the amount you spend on advertising and the revenue that an advert generated, right? It may be that that data follows a sort of straight line pattern, and through that you can build a what you call a linear regression model so that you can predict based on how much money I spend on my advertising, the amount of revenue the advert is going to generate, and you get more information about your system. Right? We call that simple linear regression because the world is often not quite that simple, right? That's not the real reason behind it. Because you're only modeling one thing against another thing, right? The world is complex. Most of the time you can't boil something down to be quite that simple. And you use techniques from, you use something called multiple linear regression, right? Which it might not just be that the amount you spend on an advertising campaign influences the amount of revenue it generates, right? It could be that the keywords that you utilize influence it. It could be that the time of year influences how much revenue that's going to generate. It might be that the, I don't know, price of the product also influences that, right? All of these things can be factored into a much wider model, which is called a multiple linear regression model, okay? Now, again, everything that we've spoken about before, we discussed the theory side of this, and we then implement it in the R language, right? So you can actually then go away and use these techniques in your workplace, right? You can transpose this knowledge from the course into where you work really, really quite easily, okay? The final thing that we talk about is something called logistic regression, a little bit conceptually harder than the sort of drawing lines through data, right? Logistic regression is very good for modeling probabilities. What do I mean by probabilities? The chance that something belongs to one group over another group, okay? Let's say that you've broken down your data into big spenders and not big spenders, right? Based upon, I don't know, how often they come to your site and the average amount that they spend on your site, and you get given a piece of data, which the person on average spends £100, and they come to your site, once a month, right? You'd be able to assign a percentage chance to that person as being a big spender, right, over not a big spender, right? There might be an 80% chance that they are what you call a big spender, and therefore you may want to send them a certain class of marketing emails, right, off the back of them coming to your site, right? That's the idea behind logistic regression. Again, we dive down into the theory behind it and we implement it in R, okay? So those are the three of the key technical areas we cover. Now, logistic regression is often used in what we call classification problems, right? Classification is the labeling of something as belonging to one group or another, right? So the example I'm going to work with for this is that of what gets called in the world of sort of business words is churn propensity modeling, right? What the hell is that? Basically, is someone going to keep subscribing to my video service or not? Okay. Logistic regression can be used to give a percentage chance to whether someone is going to stay on my video streaming service or not. And it can also be used to assign a label as to this person is going to stay, this person is not going to stay. Okay. This is what all classification is built around. Okay, so logistic regression can also be used to classify. However, we go through 3 more very popular and really very powerful classification techniques to do this. Classification forms, in fact, the majority of data science that goes on in the workplace, right? Because you often want to label something as being one thing or another thing. Okay, massively useful. We talk about 3 methods. They're 3 methods that kind of come at the problem from different perspectives, right? One of these is called k-nearest neighbors, which simply says if a data point is near some other data points, then it's probably like those data points. That's how that works. We have decision trees, which pose a set of questions to your data, asking, oh, do you spend more than £300 when you come to my shop, right? And off the back of all these various questions that you ask, you put them into one of the categories, okay? And we then also have what's called naive Bayes, right? Built off the back of probability theory, right? Which essentially assigns, okay, what's the likelihood that someone fits into all of these, what's the likelihood that someone possesses all of these attributes or labels? What's the likelihood that this person watched? Oh, I don't know. What do people watch now? I think Bridgerton's a thing, right? If someone watched Bridgerton, The Thick of It, and, oh, I don't know, is it Bill and Ted's Magical Adventure, something like that, right? Can I assign a probability to those, and can I use that to decide whether they are going to leave my subscription service or not, right? That's the idea behind naive Bayes. 3 different ways of looking at the same problem, all massively useful in their own ways. And again, we implement these in R, okay? So, and then the final thing that we talk about in our analytical theory and method, what the final thing that we talk about in analytical theory and methods is our time series analysis, which if you're ever doing any kind of forecasting, be it for stock prices, be it for your revenue, be it for anything where time is a factor in it, you will have people performing time series analysis to give reasonable forecast as to what the value of something is going to be, right? And we cover that as well in the course. And there's a bullet point I forgot to include in there. We actually do a deep dive into text analysis, right? Which again is a huge area in data science, right? That of natural language processing, techniques that are used within it, the things you can do, and again, it's all implemented in R, right? The body of this course is really, really fantastic in terms of the variety of material you get to cover. There is, without a shadow of a doubt, something in it for everybody, okay? So that's what the body of the course is concerned with, right? These analytical tools, theories, methods, right? Which we get a sort of a scientific understanding of, and also a practical understanding of. And then once we've covered all of these, we start thinking about specific places we may want to implement them, in a sense, right? And as I've mentioned, there's this whole world of big data out there now, right? And we move on to discuss sort of big data technologies and ways that we can implement all these analytical methods in these sort of big data tools, right? So we're going to talk about Hadoop, we're going to talk about Hive, we're going to talk about the whole what's called Apache stack of big data tools. If you work in an organization who is handling large amounts of data, streams of data, all these sorts of things, then these big data technologies are of massive relevance to you, okay? So that's an overview of what we cover in the course. I think it's fantastic, and I'd love to see people on this call attend, right? It really is great what we cover, right? Unrivaled, I think, by a lot of providers. And what's not least important about it is the fact that you also have the opportunity to achieve a certification at the end of it, right? EMC DSA is a qualification you can obtain, which states that you have an understanding of these concepts and how to implement them. And there is really, in the market, nowhere else where you can obtain a qualification like this, independent of specific technologies, right? The only dependence it has is on the R programming language, which isn't really owned by anyone. It's open source, right? You don't have to tether yourself to a specific provider to be able to demonstrate your understanding of these things, right? It really is a general course that exists away from, let's just say, a large corporation, right? It does say Dell EMC, right? But you don't have to learn anything about specific Dell technologies within it, which I think is quite cool, right? I think it's quite cool. Okay, so that's what the course covers, right? What can you do with it? Hell, what can't you do with it, right? So I've got down some more examples where data science often gets used, right? I've spoken about a few of these already, right? That uncovering of hidden customer categories is something you're able to go away at the end of your course and implement right away, right? The suggesting of items commonly bought together, right, is again something you can go away and immediately do, right? However, this applies to anywhere where you have categories of thing being consumed together, right? Estimating life expectancy is a place where regression gets used a lot. The prediction of customer churn. So many companies are subscription-based companies now. And so being able to estimate whether someone is going to leave or not, massively valuable because you can target certain kinds of communication to them. And the forecasting of revenue is a massive use of things like our time series analysis. Okay. And there's so much more. We've touched on a few problems here. But as I'm sure you're aware, the world of data is only growing, right? There are so many problems you can solve. Your company will have really specific problems that you need to solve. It will also have really general problems that you will need to solve. And data science is the place where you can look for the tools to solve these problems, okay? Which you can, of course, learn on this course. And then where do I suggest that you go next, right? Next steps you might want to go on. You have all the tools by the end of this course to start your own project, right? Yes, do good things for your company, right? But you can also work on projects in your own spare time because it is so interesting. When you get hooked, you're hooked, okay? There are platforms which run competitions that you can enter, such as Kaggle, right? There is a wealth of data, publicly available data, data that is just out there for people to analyze in the hope that they find something interesting. There is so much of it out there in the world now that you can really get started on your own project, build a hypothesis about some problem, right? Start thinking about what you might want to try and uncover and just put into practice these skills that you would learn on the course, right? That's the biggest recommendation I give in terms of next steps, right? However, you may want to get to grips with another programming language I've got down here, right? So R is one place where you can do all of these cool things. However, most programming languages now have some implementation of all these cool tools and techniques that you may want to use, right? All the theory behind these tools can be transposed into another programming language really quite easily, right? Once you've got that grounding, you can really apply it in sort of any language or domain or tool that you would like, as long as it has provisions for it. Even if it doesn't, right? If you understand the logic behind it, you can build things from scratch if you really want to, okay? I've got a nice vague thing, explore AI offerings, right? We had our graph where we had business intelligence leads to leads to data science. The sort of thing that consumes all of that is the world of artificial intelligence, which is again sort of a next step beyond that, more technical. But again, there's a world of AI out there, which your understanding of the techniques in data science can be used to start you off on your journey into that domain. And then, of course, you can tether yourself to one of the big platforms, right? Every cloud provider has some kind of data science provision, machine learning provision, or indeed AI provision, of course, anything like this, right? Once you've got that base level understanding that you get from this course, you can learn how to apply it in sort of larger problems, in platforms, in off-the-shelf solutions, okay? It really is a great place to start your data science journey. Okay. Any questions? I have no idea what time it is. Have I there?
It's 20 to 11. So thanks for that, Thomas. Great stuff. Yeah, so we're going to open up the Q&A session now. If anyone has any questions, if you could pop them in the chat, and I'll repeat them to Thomas. In the meantime, I'll start it off if that's all right with you.
Absolutely fine.
So why would you recommend EMC DSA over other data-related courses?
Because you get a certification at the end of it, which is really hard to get unless you, for example, enroll in say, a university course, a recognized professional certification, and because that certification isn't tied to what do we say, a specific vendor, right? You're not learning, I don't know, name a big cloud provider. You're not learning their data science course. You are learning just the foundation of data science, which can be universally applied, right? And to be able to get a certification for that is, again, something that you really don't see anywhere else.
Okay. Strathler has asked, is it mandatory to have a PhD to get a job as a data scientist?
No. It's mandatory to be able to demonstrate practical work, I would say, right? But it really is a field which you can sort of work your way into. But look, if you understand the ideas behind data science, why things work the way they do, how to make things work, right? There really isn't that high barrier to entry that was sort of assumed, I'd say, about 5-6 years ago. Okay, it really is a massively growing area, and the sort of statistical underpinning that this course will give you is a great place to sort of base that a great thing on which to base that progression, right? So no, you don't need to be a PhD. I'm not a PhD, right?
Swindon has asked, what are the prerequisites for the course?
Remembering how the equation of a straight line works, having worked with some technical, I'm going to say language here, right? It could be something like VBA, it could be something like SQL, could be something like Visual Basic, right? Having that grounded, like that's not essential, but it's hugely useful, right? Because that will allow you to learn how to implement these things much more quickly. And yeah, look, just willingness to learn, curiosity, right? I explain everything in the course if you have me teaching it, right? I explain everything in the course in multiple different ways, right? There might be an equation on the board, but I will give you an intuitive understanding of it as well as a practical implementation of it, right? So you can really come at it from so many different angles, and based on what you're most comfortable with, you'll be able to pick that. Yeah, you get the idea, right? I often lose my sentences.
Ali has asked, how does Python compare with R?
Oh, I mean, how does Python compare with that? So, I mean, Python is, I would say built on a stronger set of rules, in the fact that it's built on sort of like the rules of programming. However, okay, so that's one of the main things, right? It's built on a stronger set of rules, right? There are things in R that don't really fully make sense sometimes, right? But like that's coming from me, who's someone who can work with both R and Python. Both are enormously useful, and you really can like transpose your the logic that you would use in one into the logic that you would use in another, right? If you're expecting to have to implement your data science solution in some piece of software, Python is probably the more logical way to go. But then again, it really doesn't have to be, because you can compile down an R script into something that is executable, right? So I mean, they're just two different places to start looking at problems, right? One of them is more programming focused. One of them is more sort of dreamt up by scientists for statistical computation focused, right? But they both have their pros and their cons. And hell, learn both if you can.
Marlon has asked, aside from this course recommendation, what would your recommendation study path be on our journey into the data science field?
I mean, it really depends where you're coming from, I suppose. Just read as much as you can about it and understand as much as you can about it, right? I gave the example of the Kaggle platform, which is a really, really great place to sort of see what data science looks like in I'm going to say in practice, right? In trying to solve problems posed in competitions, a really great place to just go and look at like what other people's work looks like, right? However, if you don't feel like you understand the sort of technical implementations of these things, then maybe get started understanding, you know, a programming language, a scripting language, a language like R, right? Or even then, right, you can do a hell of a lot of data science in Excel these days, right? You don't have to be mega technically apt, right, to get your sort of first foothold there, right? Just be interested, read up on things, right? There are so many fantastic resources out there. But yeah, what's my main recommendation in terms of trying to get into it? Run as many projects as you can, document all the projects that you run. And I mean, that is the best thing you can show to any employer, right? Qualifications, yeah, good, fine, right? But if you can show you are able to do what you say you can do, hands down, that's the best thing you can do.
D. Heaton has said, which R libraries does the course use for the modeling?
So the majority of it is sort of, a lot of it's done with base R, right? And we pull in certain libraries for certain tasks. I can't remember the names of them off the top of my head, if I'm being honest. But I mean, it's sort of the starting point you would want to have for performing your modeling, right? So we just go with the most widely used modeling libraries for each of the techniques we want to implement. But again, there are so many libraries out there that, you know, when you learn how one works, you can get a feel for how all these other ones work. Sorry.
Someone's asked, can data science method be, can data science method apply to investigating data forensics?
Yes. Yes is the answer to that question, right? They very much go into hand in hand, right? I kind of, the way I see data science is sort of a toolkit of sorts. It's a way of thinking about problems, but it's also a toolkit of sorts, right? Whose various pieces of it you can pull out and apply to most problems to do with data, right? So yes.
Yeah. Would having forensic knowledge of for knowledge of manufacturing KPIs and data trending be helpful in understanding data science?
Absolutely, right? Look, if you can read graphs, you're kind of halfway there for a lot of these techniques, right? The best way to understand a lot of the sort of techniques behind data science is visually and graphically. So if you have experience in sort of understanding trends and what that actually means, yeah, massively useful.
Brilliant. Nick has asked, what does EMC mean?
Oh goodness me, that's a good question. I think there's another company that was subsumed by Dell, right? So the DSA is the sort of relevant bit, which is Data Science Associate, because that's the name of the qualification that we teach to. However, EMC is, it's the name of another company. I don't know off the top of my head what the qualification itself stands for. Sorry, what the acronym EMC stands
the acronym, yeah.
Dell is Dell, right?
Just a lot of thank yous. Will data science course be useful to someone working on CRM applications?
Yeah, I mean, if you want to take the next step or learn about what a potential next step is going to be, getting a grounding in data science is fantastic for that, right? But yes, right, every tool we discuss can be used for tasks to do with data, and CRM is a place where it's very widely applied.
Brilliant. Ula has asked, will data science be useful for someone with information security or cybersecurity background?
Yeah, I mean, it gets quite widely used in anomaly detection, threat detection, and if you're interested in getting to grips with how some of the some of the sort of cybersecurity companies that are really exploding right now work. So an example comes to mind, which is someone like, I think they're called Darktrace. Darktrace use machine learning, which is a tool used in data science, machine learning to essentially identify threats, right? So it's already being used in the world of cybersecurity, right?
Brilliant. Do we have any more questions? We have about 8 minutes left. If anyone has any more questions they'd like to ask. Lots of thank yous to Thomas. I have a question. If I were to take the EMC DSA, how would I progress after that? Would I have to retake the certification exam every few years, or is there a career pathway that leads me on to something next, or is it simply I achieve this certification and I'm in this role and I learn on the job essentially after that?
I mean, the way that I see the qualification is, it's not something you have to recertify. You have the qualification; it shows that you have a core understanding of these concepts. But I would say for the vast majority of people, it's kind of the start of a journey, where with the skills you learn on this course, you can go ahead and run your own projects or run projects within a company if you work for a company, right? And get that, let's call it intuitive knowledge, right? Or build up a portfolio, which will show a future employer or indeed your existing employer, that you know what you're doing. But it's the start, right? Sadly, you can't sit on the course, get the certification, and be like, well, I'm a data scientist now, pay me £100,000, right? It's not quite that, right? But it's the beginning of a journey to get towards that.
Okay, brilliant. Neil has asked, how is a student assessed during this course for the different modules?
So there's the final exam is the sort of like, big end assessment, but we utilize quizzes throughout the course to test understanding of concepts. And in the sessions where we're working with R and R scripting, the instructor, be it me or someone else, essentially will go around and evaluate your R script that you've run. And of course, there's sets of answers on which you can compare what you have written to. Okay, so there's really sort of like a wide variety of continuous assessment that goes through it. We review every module, you know, so on and so forth. But yeah, you're sort of being continually tested throughout before you do have that final exam on the last day.
Brilliant, thank you. So it's 5 minutes left. I will say really quickly, Peter, the course duration is, let me get it up for you real quick. You will all be receiving a follow-up email with a recording of today's session, and I will send you a link to the course page that we have, as well as contact details for our sales team if you're interested in signing up to the course, or if there are any other questions that weren't answered today or you've thought of since the webinar's finished or anything, you're welcome to contact our sales team directly and ask them yourselves. Everything is on our course page though, so prerequisites, duration, cost, etc. So please feel free to have a look on here. I can tell you right now that the duration is 5 days. Firebrands specialize in accelerated learning, which means most training providers will teach you this course in about 6 to 7 days, but we make sure we get you trained and certified with finishing your exam within 5. Just to make sure that you return to the office an expert and you don't waste any time basically in training. Make sure you get certified as quickly as humanly possible. But I've sent the link in there in the chat box, and I will be sending it in a follow-up email. And again, please get in touch with any of our salespeople if you have any other questions. There is one last question Diego has asked. Hi, Thomas. Thank you for the informative session. I would like to eventually progress to learning MATLAB. Will this course give me foundations for it?
This course won't give you a foundation for like MATLAB specifically. However, the things that you want to do in MATLAB are covered in this course, if you know what I mean. So again, linear regression in one language is going to look roughly the same as linear regression in another language. Building a classification model in one language is going to look roughly the same as building a classification model in another language, right? Behind it all it's the same theory, right? So we don't touch on MATLAB itself, right? But the tasks that you want to complete in MATLAB, right? And also just developing an understanding of how programming languages work. If it's your first time, it may not be your first time, I have no idea, right? Are all helped by this course, okay?
Just to refer to D. Heaton and Phil, how is this course delivered just given the COVID situation? Is it online? Absolutely. If you don't mind me answering this, Thomas, absolutely. Everything is online at the moment. We're following the government's regulations and guidelines, and we keep up to date with them on the daily. So at the moment, we have closed our training center. Everything is online. We're hoping to come back come you know, as soon as we're able to, essentially. And then from there, we have a COVID-19 response page, which I would sort of, you know, recommend you follow. It gives all the updates as soon as we get an update on how we can deliver our courses. So for majority of 2020, we have been doing a mix of classroom and online, and we've established a hybrid form. You know, when we can open our training center, we do, and when we can't, we restrict it to online. But our point is to make it as feasible for all of you to keep learning and keep getting certified. So I'll put on here real quick the COVID-19 response page for all of our updates, personal like how the company is running. And you can also check on our website how our online training works. But I will be putting all of these details in the follow-up email.
Yeah. I mean, I've run the course through COVID a few times, and it does work well remotely, right? I mean, you can have the choice of a virtual machine to run your sort of R session in, or indeed it's an open source software, so you can run it off your own. We have video, I'd say lectures, questions and all these sorts of things, right? And it's also like possible to run like whiteboarding. I love whiteboarding, is crucial in all of this. I've learned how to use one of these daft things, right, with a pretend pen. Yeah, so everything that I would do in the classroom, I can do remotely. And it works. People have been passing, right? It's good.
Yeah, exactly. Yeah. Okay, so it's 11:01. I think we're going to round it off there if that suits you, Thomas.
Yeah, fine, unless there's any other questions.
Yeah.
Like you said, I'm more than happy to answer questions. If you get emailed them, then I can, let me know.
Brilliant. Thank you. Will do.
That sort of thing.
Yeah, brilliant. Well, thanks for joining your first sprint. I'm sure we're going to book you on very soon again.
Oh, I've seen one come up in my schedule in the future. Yeah.
Yeah. Thank you everyone for joining. It was great to see so many of you on here this morning. Have a lovely weekend. You'll be receiving a follow-up email shortly with all of the necessary information, and I will include information on our online instructor learning training and our COVID-19 response page as well. And if you have any other questions, you can email me at sprint@firebrandtraining.com, or you can get in touch with one of our sales team who will give you directly more information, the upcoming dates of our EMC DSA, and whatever you'd like to know. So thank you, Thomas, again. Thanks, everyone, and wishes for a lovely weekend.